All right, feels like forever. But we are back, and we're in part three, and we're dealing with some algebra. So here's the deal: don't get freaked out by this algebra. What this, excuse me, what this is testing is whether or not you know what it means for two things to be congruent, and whether or not you can use that information to solve some pretty set up and solve some pretty simple algebraic pieces. So here's the thing to note: that is really important because that right there tells you actually how you're going to set these pieces up. Because remember, the name, the order of the name actually matters quite a bit. So this tells me that for figure A, B, C, D, A corresponds to A prime, B to B prime, C to C prime, D to B prime. I'm not going to be deceived by the picture because the picture is going to be easy. Or it's going to be easy, excuse me, for the picture to fool me if I let it. But instead, I'm going to make sure I have that in mind. And as I look over to my picture, I'm going to try to make sure I am aligning the pieces. And here's what I mean. Um, my congruency statement over here tells me that AB corresponds to A prime B prime, which means that 2W corresponds, in this particular case, to 50. Tricky, right? That was pretty tricky. Yeah, it was. So 2W goes to 50 in this case because it's not the way the picture looks. It's a congruency statement that I was given because nothing is assumed to be to scale. So in the same way, I have BC, which I'm going to code in blue, is actually going to be congruent to BC, which is B prime, C prime, excuse me, which is there. Uh, AD is going to be to AD, and orange and DC is going to be to DC. So now that I know these pieces, now I can go back and actually set up and solve some equations. We're going to find that actually be too tough. So if I look at AB, which is 2W, it's got to be congruent to A prime B prime, which is 50. Congruency guarantees equality. Therefore, 2W is equal to 50. And so W in this case is equal to 25. Rock on. Moving on, let's go to blue. We have blue BC, which is going to be 3y plus 30 is going to be equal to B prime C prime, which is actually going to be 60, referring to the diagram, of course. So if 3y is equal to 3y plus 30 is equal to 60, 3y is equal to 30, which makes y equal to 10. Not too shabby. Okay, moving on to orange. We have 3z plus 7, which is congruent, which means equal, to d prime c prime on the right, which is going to be 10. So we have 3z plus 7 equals 10. And that's going to make z equal to 1. Algebra. Pink. Okay, so we have 7x plus 2, which is congruent and therefore equal to a prime d prime, which is 30. So we have 7x plus 2 is equal to 30. That's going to make x equal to 4. Yay for algebra. So the tricky part here is making sure that you keep everything aligned and aligned correctly because that's very easy to trick yourself on. All right, so same kind of thing here. We have to pay really close attention to this. So x, y, z, y, w, v, u. So let's check the order here. So x, y, z. So I'm going to put a little dot at my starting point. X, y, z. Where's okay? X. So x, then it goes up to y, over to z, and it's going to go around the figure. Is going to correspond to n, p, w, z, s, t. So starting at n, and then I'm going to be heading that way around the figure, which is going to help me ultimately figure this out. And again, I'll try to color code this to make it a little more clear. So that means these two pieces are corresponding and congruent. These two pieces are corresponding and congruent. Let's see. These two pieces are corresponding and congruent. And orange. These two pieces are corresponding and congruent. Okay? So again, so that's really about matching the pieces, and now we have the pieces. We observe that congruency means equality in terms of measurement, and so now we can start putting these pieces together. So I have 12 is congruent and therefore equal to negative 3a minus 3. So if that's the case, a has got to be negative 5. Okay. What do we got next? Pink? Okay. So pink we have 13 is the same as 2d minus 5. Which will make D, if once we kick the 5 over, make it 18. 9 and 9 make 18. Yeah, okay, so D is equal to 9, which has some kind of nice little symmetry going on there. Let's see, deep purple. So we have 4c plus 16 is the same as 8. So let's see, that'd be c is equal to negative 2. And then orange, b minus 9 is the same as 21. So b is going to equal 30. Okay. So again, got to pay attention to the congruency statement, but once you got it, it's just about matching the pieces you have. So here's a pretty easy one. A, B, C, D, E, and then we have E, F, G, H, A. Okay, let's take a look at this. Oh, it's bananas. Let's start marking it out. So we have A, B, congruent over here to E, H. I'm sorry, E, F. There is no E, H. Okay, we have B, C. Where is B, C? Doesn't matter, there's no marking for B, C. So we have C, D. That's 21, but there is no C, D. We have D, E. Here we go. Congruent to HA. Bam. Let's move it out a little bit, actually. Okay. Now, there's a little twist in this one. And the twist in this one is that there are some angles in play here. But we have everything kind of really nicely labeled, so it shouldn't be too difficult to figure out. So we have this angle here should be equal to 90. And I can kind of tell it just by the way the other corresponding pieces are folded out. And then we have this 120, which would be the same as negative 10z plus 20. All right, so now it's a matter of mapping these bad boys out. Okay, so let's see. Let's do, since I'm holding green, let's go ahead and do like 120 is equal to negative 10z plus 20. Because those are my angles that I have coded in green, the ones at D and the ones at H. And again, we can confirm those are good to go because D and H are located in the same spot in our sentence structure. So let's see, I subtract 20, so Z should be equal to negative 10. Well, let's go purple. Bam, purple. Okay, so I have 10x minus 60 should be the same as 90. So let's see, I add that 150, so x should equal 15. Orange, we have 10 is the same as 3w plus 1, so w has got to equal 3. And last but not least, we have 8 is the same as negative 3y plus 2, so y is going to equal negative 2. Yeah, because minus 2 makes it 6, so that way 3 is negative 2. All right, one last one for this set, guys. It looks like I have a small edit here. Measure of angle GHE should be 10y minus 5. Okay, yeah, we have a little error here. So that's 10y. Man, that was terrible. Okay, so that's 10y. Okay. All right, so this hopefully is becoming a little bit repetitive, but that's okay if it is. Let's start marking the congruent pieces. Here I have DC and HE. So DC, boom, HE. Oh, look at this tricky one. Bam, that's right there. Which actually is a no color because, I mean, it doesn't look the same. But what's important is, again, the drawings here is out of spec. So we have CB and EH, CB, and EH, EF, excuse me, EF. Okay, so again, if you're looking at this and saying, well, Mr. Collins, they don't look alike, remember, none of this was ever guaranteed to be to scale. So you can't go by what you see, you got to go by how it's marked. Anyway, we have BA and FG, so BA and FG, okay? Now that does it for the perimeter. Oh, sorry, we have AD. It does not do the perimeter. We have AD, which is wrapping around from beginning to end. The same as HG. HG here. Oh, okay, we don't actually need that one. Never mind. My fault. But this is helpful because we do have a couple of angles here we're going to have to try to figure. So using our color coding, we can see these actually arranged the same way. So 110 should be the same as 9z plus 11. And this 10y minus 5 should be actually the same as 85. So now we have it all color-coded. Let's actually now do the work, and I'm going to kind of spread this out. So let's do the y first. So I have 10y minus 5 is the same as 85. So y is equal to 9. Let's see. The blue here, we have 110 is the same as, because they're congruent, as 9z plus 11. Is that right? Yeah, that's right. Okay. So I take and subtract 11 over here. I should get 99 is equal to 9z. So z is equal to, let's see, what's that, 11? That's weird. Look at 9z. Let me fix that before it drives me crazy. All right, let's see what's next. Let's go red. Okay, so red is going to be 40 is equal to 7x plus 5. So x is equal to 5. Orange we didn't need. How about dark blue at the top? 27 is the same as 5w minus 8. So w is equal to 7. I think that does it. Let's see. Yeah, got x, got the w, got the y, got the z. Yeah, it's all 4. All right. Okay, so that's the first part of the algebra. I'm going to break this, like I said, up into a couple pieces so the video doesn't run crazy long, because it's right about 10 minutes. But those are the 4. Again, the lesson learned here is a couple things. Number 1, the name. The name means a lot, because the order tells you everything. And number 2, you can't trust the way it looks. You got to look at how it's actually named, and then, of course, do some marking. I had the advantage of doing the marking here in color, but of course, you could have substituted color by doing like tick marks. So let's say like you're doing this on a test and you want to make sure that you're doing it really well. Well, of course, a good tactic you could use instead of coloring this pink would be like 1 tick mark. And then this one, this red would get 2 tick marks. The top would get like 3. The bottom would get like 4. And then for the angles, you could be like, well, that's 1 arc, but I'll make this one like 2 arcs to make them different. So just because you don't have color to your advantage doesn't mean that you can't, say, still do this really well. Um, it's just a matter of marking things so you're able to see them. And that's really it. We're just taking advantage of digital ink. All right, so I will see you guys in Algebra Part 2.